So I'm so happy to be here today, and I also see so many new faces, which is really nice. I have a couple of questions for you. So, who is attending PyCon Italia for the first time? That's pretty good. That's pretty good. Okay. Who is from Berlin? Who is from Berlin? Okay, that's good. Okay. Okay. Who is vegetarian or vegan and is not from Berlin? Are you vegetarian? Okay, cool, cool. Do you know this guy? Yes, no, no. Okay, this guy is Mark Andreessen. Is a venture capitalist. He's the co-author of Mosaic, the first browser, and one of the co-founder of Netscape. And a couple of years ago, he wrote an article for the Wall Street Journal with the title "Why Software is Eating the World." And the article is really interesting, and he tries to explain why software is reshaping our life and changing the world, much more than any other branch of technology. So if you compare, I don't know, to hardware, for example. And today, I would like to take the sentence and rephrase that sentence a bit. So I would like to ask you another question, and the question is, can software feed the world? So before trying to answer this question, I have another one, and is, why should we bother? Does anybody know today's world population? How many people are on this planet today? 7? 8? Okay, it's 7.7 billion. And do you know the population of the world? I mean, the population that will be in the world by 2050? Any guess? 12? Twice? 15? That's a lot. I mean, there is no space for everyone here. No. By 2050, will be 9.8 billion. And this is a huge number, and I mean, this number will put a lot of pressure on our ecosystem. And to feed the world population by 2050, we need to increase the food production at least between 25 and 70%. But it's not the only big change. There's something else that will increase. Do you know what percentage of the population today is living in urban areas? More than 50%. Yes, right, it's 53% today. But by 2050 will be 68%. So more or less, more than 4 billion will live in urban areas by 2050. And if you think for a second, do you think we can keep moving food around in that way? Can we keep producing food far, far away from consumers? So if we consider together the growth of the world population and the migration towards urban area, we can see that we are creating big problems, but also big constraints. So first, yes, we want to feed those people, but converting more land to food production is not possible. I mean, it will be counterproductive. We cannot destroy more forests. And also, people from developing countries, they will become wealthier, and which means that the food consumption will change and increase at the same time. So they will have habits that they are more similar to our. So we have some big problems. So first, we need to avoid hunger. We want to make cities more sustainable. We cannot increase croplands, and we cannot terraform the sea, which is more or less 70% of the surface. So what should we do? How do we fix these problems? So many solutions have been proposed, but we can summarize them in 3 categories. The first one is we should change our diet, because it's not sustainable to use cropland production to feed animals and then use the animals to feed us. That's the first step. That's one of the possible solutions. The other thing is that we should reduce waste. So today, between 30% and 50% of food production is wasted because before it gets to our plates, which is a huge number. And the last thing that we can use, the last lever, is technology. So we can use technology to increase group yields, for example, or we can use technology to think about agriculture. And here it comes InFarm. So I work for InFarm. It's a farming as a service company. We are based in Berlin. I'm a senior software engineer there. And that's what we do. So what you see here, what do you think is? It's a fridge? Looks like a fridge. It's a farm. So this is a shop, I think it's in Berlin. The shop is called Edeka. It's the largest German retailer. And we produce more than 120,000 plants for them every month. So we use indoor farms that we have developed during these years to grow something like 35 different types of crops locally nearby the cities where we operate. And we operate about 400 farms with the goal of reaching 1,000 by the end of this year. And like I said, 100% local, 0 pesticides, and we don't have the concept of season, because every month is a good month to grow something inside a farm. So let's talk about code and hardware, because that was a small farm. We have another one. So that's the mass production farm. It's the farm that you can see inside our production centers. We have one in Berlin, near Tempelhof. And it's pretty big, actually. I think it's about 8 meters. And just to give you more context, we have about 4 weeks from the seeding phase to the harvest. So in 1 month, we can grow and we can harvest almost everything. And as you can probably imagine, a farm is a super complex living system that we want to operate, we want to control, and we want to monitor. So what do you think we can control inside a farm? Any idea? So lights, right? Water, it's fundamental. No humidity, we don't control directly humidity. We have air control. Sorry? No, we don't control temperature. We don't have soil. Sorry? Yes, it's hydroponic, no soil. So we control the pH, that's another fundamental thing, and then we control nutrients, fertilizers. So lights, water, air, pH, and fertilizers, that's what we control. And I mean, we need to do this at scale. We have 400 farms in Germany, in Paris, in UK, and in multiple locations, also inside the grocery shops. And because this is a Python conference, we are using JavaScript. Now we are using Python. So as a software team, we have 4 areas of focus, what we call pillars. So one is operation, the second one is farm control, then we have monitoring and alerting, and the last one is plants quality. So operations. So operation are all the activities that are related to a farm, like seeding, we have harvesting, we have cleaning, maintenance. And then we have farm control. So like I said, we can control something inside a farm, like water, lights. And a collection of these parameters is what we call a recipe, which is a configuration. And usually we send a configuration, a recipe to a farm, then there is an IoT device inside the farm, is a farm controller, and the farm controller applies the recipe, the configuration to the farm, like the quantity of lights that you need to provide or the level of water. And the other pillar, the third pillar, is monitoring and alerting. So a farm under the hood is a complex and very expensive IoT system. And we constantly receive data and events coming from the farm. Like, I mean, no water, it's a big problem. You have like 30 minutes, and then all the plants are gone. Is the pH too high? That's another problem. So monitoring and alerting is crucial to support our operations. And then we have the last pillar, the new one, is plant quality, because you need to do data science and artificial intelligence today. So the idea is to use data science and artificial intelligence to increase the production and the quality of the crops. So now I want to talk a bit about the past. So when we started, we thought about building a product for home consumers. So if you check online, you will see something on Kickstarter, like a campaign by the founder. And they were running around Berlin with a truck, with a van, teaching people how to grow plants inside their apartments in, I think, Kreuzberg, which is really nice. But in the last 12 months, the scope changed completely. And also the focus of the software. So from home consumers to B2B business. So initially we had like a very small team with a big monolith Flask application, which is not really nice. All the business logic, all the pillars were inside that application. So operation, farm control, monitoring and alerting. And for job scheduling, we heavily rely on salary. But as soon as our business model changed, we started having issues. So what you can see here is our current technical debt. So we have scalability issues. The software is not providing anymore the flexibility that we need to grow as a company and also as a software team. We really have too many unmaintained dependencies coming from Flask plugins. Sadly, we suffer of something that I can call like leaky abstractions. And the last point is really important because it's something that I call normalized. If you know the concept of clean architecture, that's normalized. I mean, we are too much focused on OREM, and everything is mixed. Business model, connection with the database, the way in which you save the data, and it's really hard to evolve from that. And also, I mean, we started using containers since a couple of weeks, but before that, we didn't have Docker or containers. And anything related to reproducibility was really hard, even to start to, you know, having a local development on your computer. And we started also fighting with Heroku, which is super nice if you start with something on Heroku, but as soon as you start growing, you don't have the flexibility that you need. And then we were suffering the lack of usable metrics and logs. I mean, I have no idea about the latency of our application today, and it's something that we need to fix as soon as possible. And also the number of errors, like 40x, I don't know. I have no idea about the endpoints or the number of calls that we get on the endpoints. And also, like I said, all the pillars were inside this application that we call Compost. And we were ingesting data and doing alerting directly from this application. So basically, we were killing the performances of the application. And for a reason that I can hardly understand, we decided to split our application on, I mean, our software on 4 different cloud providers. So you can name it. We were using Heroku, we were using DigitalOcean, we were using AWS, we were using GCP. Yes, 4. Yes, just to try something. So we decided to evolve, we decided to grow, and we decided to work on 4 different levels that I call consolidate, architecture, cloud native, and observability. So we decided to deprecate all the cloud providers apart from GCP. So S3 will become cloud storage, and AWS Lambda would be a cloud function on GCP. And like I said, paying technical debts is crucial because we want to keep a high degree of flexibility. So it's extremely important. I mean, I don't want to hear things like, we cannot build that feature because it's too hard to change the software. That's something that you want to avoid, especially if you're growing as a company. And then yes, I love linters. Do you love linters? No? Yes? Yes. Okay. Are you looking for a 10x developer? Just give him some linters. We are using Flathead, iSort, and Black, and all of them are part of our CI, so you cannot merge something if they're not green. And we are also experimenting with MyPy, which is the static type checking in Python. And another very, very, very important point is that we don't run any part of our infrastructure. So we don't build things, we prefer to buy things. We don't like unmanaged service, we prefer to have managed service. The second level is architecture. So like I said, we are moving towards a more service-oriented architecture, maybe Pulmeni, maybe Ravioli, I don't know yet. And we will try to keep a very strict service separation. And also the plan is to don't add any new functionality to the monolith. And a very, very important step, something that we just recently completed, was to remove the data ingestion part from the monolith to cloud functions. And that's pretty cool because we don't do only data ingestion using cloud function, but also dashboard provisioning. So you can think about a farm like a system, like an edge point in your network, and you want to monitor that network. So you have a dashboard for 400 farms. And every month we had new farms, and we want to create a new dashboard, and we want to do this automatically. And we don't want to, just to create a new dashboard. We also want to update the dashboard depending on the data coming from the farms. And that's something that we can do using Cloud Function. And we're using Python 3.7. So this is a blog announcement from the GCP DevRel. And we are mentioned there in farm, yes. I think they just announced general availability for Python 3.7 and GCP Cloud Function, which is really cool. And yes, we are using them, and they work really well. So what about Cloud Native? So the first thing that we did, especially when I joined the company, was to migrate to containers. Everything is a container now. Also inside Heroku. So we are running containers inside Heroku. It doesn't work really well, but I'm fine with that. And we also started to introduce infrastructure as a code to declare our infrastructure, which is really important. I mean, I don't want to fiddle with the user interface of GCP now. And the plan is to migrate to Kubernetes. So we started playing with the testing environment, and the goal is to migrate all the services to Kubernetes, to GKE by the end of the year. Observability. Have you heard about observability before? You? No? It's like a new concept? Yes? No? Okay. So observability is like the new thing after microservices, probably. And the thing is to have a proper introspection inside your system. So we have a very good test coverage, which means nothing, but we are just happy with this because we have 90-something and we are happy, proud of ourselves. But we lack the ability to introspect what is happening in production. Because we lack proper logs, proper metrics. So the first thing that we did also was to migrate from the normal logging standard library to struct log, which is pretty nice. Also, the next step was to have more meaningful metrics. So, especially because we wanted to be able to answer simple questions, like what are the performances of our application? What is the number of errors? Things like this. What is the latency? And this is extremely important, especially if you're a growing company, because you don't want to feel blind about your applications. You want to be able to answer simple questions. And also, we are evaluating different platforms for logging, because like I said, we don't want to run services that are not part of our infrastructure, of our core domain. And currently, we are considering Elasticsearch, the Elk stack, or Stackdriver, which is the service coming from GCP. And the cool thing about Elasticsearch is that you can also do APM, so Application Performance Management, directly using Elasticsearch. They have a new plugin for this. So what about the future? what about the future? So the first thing is that we will try to have more microservices. That's the thing. So we are moving towards a more service-oriented architecture, like I said. So farm control and authentication will be probably the next step of the migration. And also we want to complete by the end of the year the migration from Heroku to Kubernetes. And the last point is extremely important because we want to increase food production and the overall quality of our product. So we will have a more focused approach on data. And if there are like two things that will shape the future of vertical farming are automated farms and edge computing with artificial intelligence. So to make vertical farming really sustainable, we really need to reduce the human labor that you need to operate a farm. And one way to reach that point is to have fully automated farms. And like I said at the beginning, each farm runs something that I can call recipe. It's a configuration. But currently we are really limited because what is running inside a farm is a microcontroller, is a particle controller, which is very low level and is not really powerful. So you cannot really push towards the edges more computation. So you need to keep everything in the cloud and you cannot do much on a farm. And the next iteration of our farms will be more powerful, something like a Raspberry Pi on a farm. And then you can really have a lot of fun because then you can run containers on a farm. Then you can run TensorFlow inside Raspberry Pi and things like this. So the goal is to be able to move from hard-coded like configuration for a farm to be more flexible. I mean, the idea is to say, okay, does this plant really need to have more lights or not? Is this configuration still valuable or not? So you want to have more smarter farms. And that's what we plan to do also by the end of the year. So we plan to reach and to have fully automated farms with edge computing with artificial intelligence by the end of the year. So I hope you enjoyed the talk and hopefully you saw a part of the future here. And if you come to Berlin, I will be super happy to show you our farms, especially if you plan to attend PyCon in Berlin. And if we still have time, I'm hoping to take questions. Thank you.
Hi, I'm super interested in the topic because I built something similar together with my students, of course on a much smaller scale. I have one question and one thing that we did. Sure. Did you consider aquaponics, so to add the fishes to the system? Because they basically provide food for the plants. And then for the limitation of the microcontroller, we solved some of the issues that we had with our microcontrollers by moving in the opposite direction. So like the turbidity of the water and I believe the temperature as well, we did it analog instead of digital.
Okay. So first of all, just to give you more context, what we do inside our farms right now is hydroponics. So we don't have soil, we just have water, and the plants are growing inside the water. No. We are not doing that because it will be really hard to operate those farms at scale also in multiple locations. And there is also the plan to let, like Edeka or Metro to run our farms. So you really need to simplify the process. Something that we are considering, I mean, it's not something new, is to do aeroponics. So you don't use the water anymore, you just flush water to the plants. But it's more, it is more technology. That's another thing. So there is always a trade-off. And so the picture from Handicap, it's more or less like a point of sale. So it's not really scalable as approach. The idea is to have more production centers with multiple farms for mass production. And there, I mean, you don't have the problem with the controllers anymore because you can centralize many things. And the plan, I mean, the idea is to connect multiple farms together.
Hi.
Hi.
Why are you laughing?
We are not growing weed inside yet.
No, I would like to know which kind of models did you run on TensorFlow on your farm? For what? To predict what?
Wait. I mean, we just started with this. I'm working on the data infrastructure, so it's like putting data somewhere, and currently I'm fiddling with, okay, from S3 to cloud storage. We're just playing with this right now. We even don't have like cameras inside the farm, so you cannot really do like an image recognition on the plants. So the idea is to use data from, I mean, qualitative data, like, okay, this plant is really good, this harvest was really good, and then connect them to the data that you had from the farms, like the quantity of water that you gave to the farm, the lights, and all these things.
Yeah.
But about the models, I have no idea. It's like they are working on this.
Okay, and another question is, have you ever told to install some spectrometers within your farm just to recognize the color of the plants and compare your spectrum during the growth age of the plants?
Not yet. So we have the farms, and we have something that we call like a lab where we run experiment, and they track everything there, like a picture of the plant, like in 1 day, 2 days, 5 days, 1 week, and things like this. But no, we don't have yet like a camera inside the farm.
I just ask you this one because with spectrometers, with some cheap sensors, you can inspect the quantity of the water within the plants or within, I don't know, fruits or wood.
That's pretty cool. That's why we are hiring. So if you want to move to Berlin.
Yeah, thank you. I was wondering what sorts of crops can you grow in these kinds of farms, and what are the limitations on what you can grow?
So mostly they're herbs, so small plants. So if you talk with the scientists, they will tell you that you can grow almost everything there. I mean, the only limitation is maybe economical wise, but apart from that, you can really grow whatever you want. Mushrooms, oranges. I mean, it's mostly related to the business and to things that are valuable from that perspective. It's not legal yet in Germany.
No. What are you talking about, Christian? Okay. Be serious now. No, the last question is, have you ever tasted something growth in your farms?
Yes.
And?
There is no, I'm sorry, I'm from Italy, and we also grow inside our farms what we call Italian basil. I'm sorry, it's even better than the one you can buy in Genova.
Wow.
Yes.
Did you? Can you get us some
samples?
Some samples free?
Yes, absolutely. I mean, just
why?
come to PyCon. There might be the chance that we have a farm inside the conference.
Son of a bitch.
Yes.
Another one?
Energetically speaking, do you think that is a limitation to use just applications with UV lights? I mean, do you think that it would be easy to grow something in Finland and in a sustainable way, to grow tomato in Finland like in a more efficient way than in Italy in open air?
And the answer is yes, because we can control the water, which is more valuable than lights and energy, because we have like easy way to produce also in a sustainable way energy, like solar plants, but we cannot like reproduce water. It's hard to collect water. I mean, it's like a limited resource. So yes, we control water. It's if you grow something inside a farm like this, it requires, I don't know, 90% less water than growing the same plants in a classical way.
Hello.
Hi.
How much human intervention there is during the entire process?
Too much for now, and that's a problem. So there are many things related to a farm because you need to prepare the seeds before doing the planting. The planting is the part where you move the small plants from what we call nursery to the big farm, and there are many steps involved. And also, like I said, we don't use pesticides, which looks like easy, but it brings so many problems because we are also bringing disease to the plants. So we are facing many problems that, I mean, they are not really a problem from an agricultural perspective because you can just use pesticides. But if you don't want to use pesticides, you need to think differently, which is really hard, especially during the summer, because with the heat, it's much more easy to have diseases on the plants. So yes, we need to rethink many things, and like I said, we really need to reduce the amount of labor work that you need to operate and manage a farm. That's a big problem right now.
Thanks for the talk, really interesting.
Thank you.
What are some of the things that you get alerted on? Like, how does that look like? If you get paged, is it like no water, or what kind of things go wrong?
Like many things. It's really up to the farm manager. So we have like farm location and farms inside the location. So it can be water, it can be that a value that we are controlling is outside of the range for that specific configuration. It's like a website. If it's down, that's a problem.
I'm not kidding you. Okay. What about the scrape rate?
Sorry, there?
Scrape rate. So that the percentage you throw.
Okay.
Okay.
So given, I don't know, like 50 plants, how many of them we
would die?
Okay, that's a problem. We call that shrinkage rate, and especially during the summer, it's pretty bad. It's like 50%, mostly for diseases. Yes, it's really tough.
You mentioned oranges before. I mean, I don't know anything about oranges, but I think they grow on a tree.
Yes.
Are you able to grow tree with it?
Sure, where is the problem? I mean, it's a system. If you control the system, you can do pretty much anything. It's really up to you. There is a company in Paris, and they grow strawberries. And they do this with aeroponics. So they have just the roots on, like, open, and they just spray water on top of the roots. You can do mushrooms. And another concept is a container farm. So basically, you have a container, and you can run hydroponics or aeroponics inside the farm. So you can move farms all around the world. Yes, that's pretty cool. But yes, I mean, it's like, yes, if you think about agriculture, I mean, we have been doing this for many years in the same way, like thousands of years ago. It's like, yes, technology can bring change also into this. There was a question here. You really want to ask something?
Can I potentially buy such a farm and grow whatever I want at home? Like, what would it require?
I guess so. You just need to open a grocery shop.
So is it possible only to buy if I have a shop?
Yes.
What if I have? What if I want to grow vegetables or fruits for my family, for example?
I mean, you can probably check the Kickstarter campaign from the founders. They explain everything there. But no, I think that currently we work mainly with big chains. So I think Metro, Edeka, I think Carrefour in France, and something else in UK, also with fancy restaurants.
One of the problems we see is the food deserts in urban areas, and the idea that people could potentially grow in, say, their own apartment building or their own homes, rather than having to find their way to a grocery store that may not be accessible or may not exist, seems like a really good way of spreading this further.
I think it's super cool. I mean, I was thinking about, okay, is there, I mean, we don't have like an open source project about farms, like infrastructure to run a farm. And I think that's the future. I mean, you can, I mean, again, it's just the technical problems. You can build something, I don't know, on Hyderfruit, and then you can build farms on top of that. It's just that. So yes, it's probably the future, I think so. There is also Samsung working on this.
Last one.
Thank you. I don't know, what kind of light are you using and how you are controlling that?
So we're using LED lights. That's everything I know about the lights. And they are controlled by the microcontroller. So the parameter is related to, so we don't regulate the intensity, we just control, yes, the hours that you want to have. Like, because plants, they also need to sleep. So yes, we just select the number of hours where, yes, we want to run the lights inside the farm.
Okay, we have the time of the last one.
last one. Not the guy with the yellow t-shirt, please.
Okay.
As you control the lights, did you also do any experiment with changing colors? Because I read the wavelengths also matter on the kind of taste and plants that you can get.
Yes, I mean, so we have a lab inside InFarm where we run multiple experiments, but also like really stupid things like changing the position of the plants inside the farm really changed the output. So you can really run like multiple experiments. I mean, this is also a platform to run experiments because you have everything more or less controlled, and in a month you can get a result. So yes, we are playing with different things. Color of lights, a fertilizer, type of plants together, and things like this.
Okay, thank you all, and thank you,
you.
Christian.